All right, so in this video, we're going to be talking about the inverse of a matrix, okay? But before we can even talk about the inverse of a matrix, we need to discuss what we call the identity matrix. So the identity matrix, denoted I sub n, is the square matrix. So that's going to be an n by n dimension. So it's a square matrix for which the main diagonal are all ones and zeros for all other entries. So for example, the identity matrix 2 would look something like this. The identity matrix for 3 would look something like this. All right. Now, we call this the identity matrix, and that's because if we were to take any matrix A and multiply it by its identity, you get the matrix A back, okay? Also, if you were to multiply the identity matrix times A, you would still get the identity back, all right? So when you multiply the identity matrix, you could do it on the left side or the right side. And yes, you heard me say that correctly. You can left multiply or right multiply. The more linear algebra courses you take, you're going to be hearing phrases like that more, like left multiply or right multiply, and that is because matrix multiplication is not commutative. So the order in which you write these matrices means everything for us, okay? But like I said, the idea behind it is if you multiply any matrix by its identity matrix, you're going to get the original matrix back out. And this will lead us into our definition of what is the inverse of a matrix. We let A be a square matrix of n by n. If there exists another square matrix, A inverse, with the property that A times its inverse is equal to its inverse times A, which equals the identity matrix, then we say that A inverse is the inverse of A. All right? So I think it's easier said if I just show you an example of how this property actually works. So we're going to verify that A equals 2153 and B, which equals 3, -1, -5, 2, are in fact inverses of each other. Okay? So what we need to show is that A times B equals the identity, and B times A also equals the identity. Okay? So, like I said, it's really straightforward. We're going to take 2153, and we're going to multiply this by 3, -1, -5, 2. Now, hopefully, you have a pretty good understanding on how we multiply matrices, because I'm going to do this actually relatively quickly. So, for the first element, we're going to get 2 times 3 plus 1 times -5. For the second entry, we get 2 times -1 plus 1 times 2. Then for row 2, first entry, we're going to get 5 times 3 plus 3 times -5. And then finally, we're going to get, for our second row, second column, 5 times -1 plus 3 times 2. And when you go ahead and you do the math, you're going to get 1001. So, check. A times B is good. All right? Now we're going to switch them. 3, -1, -5, 2, and 2153. And this also has to equal our identity. In this case, it's going to be I2, our identity matrix, which is a 2 by 2 square. So just set it up again. We get 3 times 2 plus negative 1 times 5. Then you're going to get 3 times 1 plus negative 1 times 3. We get negative 5 times 2 plus 2 times 5. And then finally, negative 5 times 1 plus 2 times 3. And notice here, you still get the same exact thing. So we just verified that matrix A and B are in fact inverses of each other. So you could put a little smiley face there because yes, they are inverses of each other. So we actually learned a lot just in this first part. We learned what a identity matrix is. We learned the definition of an inverse, and we learned how to verify that yes, these two matrices are actually inverses of each other. Now the question becomes, how do you find an inverse? So we're going to focus on the first way to do this. So we're going to find the inverse of a 2 by 2 matrix. All right. So if A equals the elements A, B, C, and D, then the inverse is going to be equal to 1 over AD minus BC times D, negative B, negative C, and A. Now, this is a shortcut. I'm going to show you how to do this, I guess the long way, but I'm going to show you using a calculator. This is the shortcut, and it only applies to a 2 by 2 matrix. Anytime you have something larger than a 2 by 2, you're going to have to use the old school method, or you can use some advanced linear algebra technique, which I'm not going to show because that's beyond the scope of this class. All right? Now, one thing I hope you're all looking at is this right here. In the inverse, in the denominator of this scalar multiple out front, all right, you have AD minus BC. Now, that actually has a very special name. It's called the determinant. And we know that we are not allowed to divide by 0. So, not all matrices will have an inverse. All right? So just because a matrix is square does not automatically imply that it's going to have an inverse. All right? Now, what's really nice about this is a shortcut formula. So I think what we should do is just take the example that we just did. So matrix A is 2, 1, 5, 3. 2, 1, 5, 3. And we're going to find its inverse. Now, we already know what the answer is because we did this in the previous problem. Hold on one second. My dog is barking. All right. Sorry about that. I don't know if you can hear him barking in the background or not. But anyways, matrix A is 2, 1, 5, 3. Let me write this 5 a little bit nicer here. There we go. And we want to find the inverse. So we just go ahead and we follow our formula, which is on the top right-hand side of your screen. So inverse is going to equal 1 over AD minus BC. Now, real quick, I'm just going to, in red, this is A, B, C, and D in terms of the elements and their positions located inside the 2 by 2 matrix. So this is going to be 1 over 2 times 3 minus 1 times 5. And then you're going to multiply this by, and if you notice, what we do is we swap the positions of A and D respectively. So this is going to be a 3, and that's going to be a 2. And then B and C, we just negate. So this will be a negative 1 and a negative 5. So the inverse is going to equal 1 over, that's going to be 6 minus 5, so it's 1 over 1, times 3, negative 1, negative 5, and 2. Or the inverse is equal to 3, negative 1, negative 5, 2. All right? And congrats, you just found the inverse for a 2 by 2 matrix. Now, I'm going to show you how to do this on a calculator. All right, because I think it's really important. We're going to do it two ways. First, A equals 4, 5, 2, 3. Find A inverse. So we'll do this by hand, and then we'll do the calculator. Because there are some things that, I want to show you that you can do on your calculator that maybe you didn't know. All right. So remember, A inverse is going to equal 1 over 4 times 3 minus 2 times 5, all multiplied by, remember, swap the positions A and D, and then negate B, negate C. So this is going to give me A inverse equals 1 over 12 minus, 12 minus 10? So that's going to be 1/2 times 3, negative 5, negative 2, 4. So if I multiply everything by my scalar multiple, I'm going to get 3 over 2, negative 5 over 2, negative 1, and 2. All right? Now, I'd love to show you how to do this on your calculator. So we're going to get out our calculator here. I'm going to turn it on. We're going to go to the matrix, and we're going to type in our square matrix here. So this is a 2 by 2. And I forget what it was already. Oh, yeah, it's 4, 5, 2, and 3. All right? So as soon as you type them in, you're going to click on the matrix button. You're going to click on the one you want. And then you can use this inverse button right here if you wanted to. All right? Or, matrix. You can go back to that matrix menu, click over to math. And do they still do this? I don't know. Sometimes they do, sometimes they don't. Depends on the calculator. Nope. They no longer provide that. So that's fine. We're just going to use the inverse button right here and just click enter. Now, if you run into this situation here where you have decimals, it's really easy to go ahead and fix that. Let me show you how to do that. We're going to go back to the matrix. We select the matrix we want. We select the inverse. And then this math button right here, directly above where it says math, go ahead and click on that. And then the very first entry has an arrow that says frac, which means we want our answer in fractions. So just hit enter. Your screen should look like this. And when you hit enter again, it's going to give it to you in fraction form, which is perfect. That's exactly what you wanted. All right. But now the question becomes, what if you don't have a 2 by 2 matrix? Is there quite possibly another way that you can do this? All right. And the answer is absolutely. Okay. So let me get rid of my calculator here. All right. So the question now becomes, how do we find the inverse of anything other than a 2 by 2? So I have an example written here. And the way that we do this is we actually create an augmented matrix between the matrix itself and its identity. So for example here, to create this augmented matrix, I'm going to write 1, negative 2, negative 4, 2, negative 3, negative 6, negative 3, 6, 15. And then I'm going to augment this with the identity matrix of the same dimension. And what you're going to have to do is row reduce echelon form this. Now, I will not force you to do this by hand. You've already hopefully demonstrated that you understand how to row reduce echelon form by hand. So what we're going to do is we're going to make our lives a lot easier. And we're going to do this using our calculator. And you can use this method for any square matrix that exists. But just remember, not all matrices will have an inverse. So let's pull out our calculator again. All right, and I need to move this over a little bit because I need to go ahead and just see what the original matrix was. So let's go into our matrix menu. We'll go over to edit. And like I said, you got to be careful here because this is going to be a 3 by 6 columns. All right. So it's probably best that you have this written down and you just go from left to right as you enter in all the elements. So 1, -2, -4, and then the identity first row, 1, 0, 0. Okay? Now you just follow that trend the whole way. So 2, -3, -6, 0, 1, 0. And then finally, -3, 6, 15, 0, 0, 1. All right. Now, if you've done this correctly, you can always just go ahead and check yourself by going back to that matrix menu, selecting matrix A, and then looking at it. And as you can see here in the big LCD screen, where my mouse is, my mouse cursor, if I had a line written right down the middle here, you can see that I have matrix A on the left and the identity on the right. Now, when I go ahead and row reduce echelon form matrix A, so RREF matrix A, notice here on the big screen, on the left-hand side in the first 3 columns, you have 1, 0, 0, 0, 1, 0, 0, 0, 1. That is exactly what is going to happen if you were to row reduce this by hand. All right. So you're going to end up taking the identity matrix that was augmented on the right-hand side, and you create that identity matrix on the left. Whatever on the right-hand side is going to be, your inverse. So notice here we have these decimals here. So what I'm going to do is just go ahead and, oops, wrong thing. I'm going to go ahead and just tell the calculator, could you please do this? Could you please give this to me in a fraction? So RREF, matrix A, and please give me the answer in fraction form. And here it is right here, nice and neat. So where my cursor is, that would be the augmented line that I would have to write. And we would get -3, 2, 0, -4, 1, -2/3, and then 1, 0, 1/3. So let me write that here. So after RREF, you're going to get 1, 0, 0, 0, 1, 0, 0, 0, 1, augmented with -3, 2, 0, -4, 1, -2/3, and 1, 0, 1/3. And this matrix, and I'll highlight it in green for us. That matrix right there is our inverse. So, like I said, and I did this, I made that announcement today. If you have a calculator, it is going to save you so much time. All right. Otherwise, you're going to have to row reduce this by hand. All right. I am cool either way you do this. All right. But it's up to you. Okay. Now, I'm going to have to show you what does a matrix without an inverse look like. All right. Because up here in the very first example that we did, remember that determinant right here, if that determinant is equal to 0, then you know this doesn't have a matrix, or this doesn't have an inverse. However, what does that look like if you were using your calculator? All right. So here's another matrix right here, and we're going to augment it with its identity. Now, if you just give me a second here, I'm going to plug this into our calculator. I'm just going to pause the video. Okay, I'm back, and as you can see here, I typed in the matrix into our calculator, and I'm going to go ahead and I'm going to find out what the row reduced echelon form is of that matrix, and if there's any fractions, I'd like the calculator to convert those decimals into fractions for me. All right. And what we have here is this. So let me go ahead and let me write this down. Here, I cheated a little bit. I just took a screenshot of the calculator output so I can write on it. So right here is that augmented part. Now, if we look right here at this row, notice how we have all zeros. Now, you got to be careful with this because remember, if you have a row with all zeros, then that means the only thing that you're allowed to have on the augmented side are zeros as well. And clearly, you do not have that situation here. So, because we have a row of all zeros, we stop and just say A does not have an inverse. That's it. So there is no way that you could create an inverse out of this matrix that we have here. And that matrix is A equals 2, -3, -7, 1, 2, 7, 1, 1, and 4. Okay? So the last thing we're going to talk about in this section is one of the most important concepts, and it's actually really, really simple. It's called the matrix equation. So the matrix equation, in all of its glory, looks like this. AX equals B. I know, I hope you weren't expecting something more fancier than that, but that's what it is. It's just AX equals B. All right? Now, A is what we call the coefficient matrix. X is going to be a column matrix. Okay, and then B is another column matrix. All right, so what we can do here is we can take a system of equations like this. X minus 2y minus 4z equals 7. 2x minus 3y minus 6z equals 5. And negative 3x plus 6y plus 15z equals 0. Okay? So we could take this system and we can create a matrix equation out of this. So that would look like this. First, we're going to do the coefficient matrix. That's going to be A. So it's just going to be 1, -2, -4, 2, -3, -6, and then -3, 6, 15. Then our column matrix is going to be the variables x, y, and z. Okay? And this we're going to set equal to another column matrix, 7, 5, 0. And this is going to be B. Now the question becomes, well, how do you solve this? Because if you remember, you're only allowed to do certain things with matrices. You can add them, you can subtract them, you can multiply them by a scalar multiple, and you can even multiply matrices. The one thing that you cannot do is we cannot divide a matrix. All right? You cannot divide a matrix whatsoever. So you got to be really clever on how you go ahead and solve this. But we already have a really good understanding on how to solve this because we understand the inverse provided the inverse exists. Okay? So to solve the matrix equation AX equals B, and I'm going to be very, very careful about how I say this, so make sure you're paying attention to this. So in order to solve the matrix equation AX equals B, the first thing I'm going to do is I'm going to left multiply both sides of my equation by my inverse of A. Now, by doing that, I'm going to multiply A and its inverse. And if you remember, by multiplying A and its inverse first, we end up getting the identity matrix. And we know that the identity matrix is always going to output the original matrix that you're multiplying it by. In this case, it'll be X. So by left multiplying both sides of this equation by A inverse and then finding the identity, which if you've done everything correctly, that's what you're going to end up with, all right? You're going to get a final equation of X equals the inverse of A multiplied by B. And that is as hard as it gets. So if we go back to our original problem that I wrote up here, so it's going to be the coefficient matrix 1, -2, -4, 2, -3, -6, -3, 6, and 15. The first thing we need to check is, does this have an inverse? Because if it does, then what we can write is X equals 1, -2, -4, 2, -3, -6, -3, 6, 15, inverse, and we can multiply that by the output 750. And if you think about this, this is a 3 by 3, which means the inverse is going to be a 3 by 3. This is a 3 by 1. So these match, which means my answer is going to be another 3 by 1 matrix. So once again, if you got a calculator, it's going to make life so much easier. So what I want to go ahead and do is I want to go ahead and just get the inverse real quick. So I'm going to type it into the calculator and then I'll show you it. So let me pause the video real quick. All right, I'm back. And I went ahead. Here's matrix A. So we got 1, -2, -4, 2, -3, -6, -3, 6, and 15. So if I just take that and hit the inverse button, ooh, and that's pretty nasty looking. So let's do this again. Except this time, let's get our answer that are fractions. So here's our inverse right here, okay? We're going to take our inverse and multiply it by our column vector 750. So we need a column vector. So I'll put this in, I guess, letter B. So it's going to be a 3 by 1, 7, 5, and 0. So now all I have to do is go back, matrix A, inverse, times matrix B. And as you can see here, my outputs are going to be -11, -23, and 7. So -11, -23, and 7, which means X equals -11, Y equals -23, and Z equals 7. So I hope this actually turned out to be a little bit easier than you thought, okay? So that's going to be it for this video. The next video is definitely going to be a little bit more in depth because it deals with this concept called partial fraction decomposition, which basically what you're doing is it's kind of like you're playing Jeopardy. I'll give you a little sneak peek. The question is 1 over x squared minus x minus 6. The answer, remember, if you're playing Jeopardy, is what are the two fractions that you added together to get 1 over x squared minus x minus 6. So we're going to figure out how to find this partial fraction decomposition here. All right, and that's going to be it for this video, so I'll see you in the next one.